We've looked at inductive reasoning, which was reasoning based on a pattern. Now we're going to look at deductive reasoning, which is showing that, yeah, we're 100% right. We feel confident in our answer, and we can show you why we're confident in our answer. So deductive reasoning is reasoning using facts, definitions, and you're going to form a logical statement. And that can be proven true. Now we have two types of deductive reasoning. One is just the really straightforward one. It's called Law of Detachment. If P happens, then Q is going to happen. You're given P happens, therefore Q is going to happen. For example, in the fall, the leaves fall off the tree. Well, it's fall right now, so the leaves are falling off the tree. So it's very straightforward. Now the law of syllogism is more like a chain rule. So if it's fall, the leaves fall off the tree. If the leaves fall off the tree, then I have to rake the leaves. It is fall, therefore I have to rake the leaves. And whenever actually you do the law of syllogism, the answer ends up being an if-then statement. Whereas on the law of detachment, you really only have just the straightforward, I can't get the E to show up, but you really just have that straightforward, therefore this happens. Let's go ahead and do some examples. You'll see what I'm talking about. So first with that law of detachment. So use the law of detachment to make a valid conclusion in a true situation. So you have to accept what you're told. So if two angles have the same measure, then they are congruent. So this is our given statement. So you know that A equals B. The measure of angle A equals the measure of angle B. And that's the first part. If two angles have the same measure, then they are congruent. Well, you're given two angles with the same measure, so then we can say that angle A and angle B are congruent. Let's go to B. Jesse goes to the gym every weekday. I would probably flip that and say, so if it's a weekday, I'm just going to abbreviate here, then Jesse goes to the gym. I don't think you want to say, if Jesse goes to the gym, then it's a weekday, because he might go to the gym on the weekend also. There's nothing that says he doesn't do that. But if it's a weekday, he goes to the gym. That's how you can interpret this. So today is Monday, and that's a weekday. So we can say Jesse goes to the gym. So whenever you're doing a law of detachment, you can just make a sentence. It's just a valid conclusion. What happens? Now in the law of syllogism, now this one you're written just a little bit differently. Your final answer is going to be an if-then statement. Let's look at an example here. If Ron eats lunch on Tuesday, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of milk. I like to set these up. I guess we could have set these other ones up, but let me set this one up and then we'll go back to the law of detachment. I'll show you what I'm talking about. These are easier to see. So Ron eats lunch. If he eats lunch, then he's going to eat a sandwich. That's the first if-then statement. Then if Ron eats a sandwich, then he will drink a glass of milk. So when you're doing this law of syllogism, the last one of the first statement should always match the first of the next statement. Those two should always be the same. And sometimes it's called a chain of reasoning. You can have multiple lines of these, and as long as the last one matches the next one, if Ron eats a drink or drinks a glass of milk, then he gets an upset stomach. As long as they keep matching up, then that's your law of syllogism. Except we're going to stop here and we're not going to have an upset stomach. So our statement then, our conclusion is going to be then, it's going to state if Ron eats lunch, then he will drink a glass of milk. Let's go over to B. In a recreational basketball league, if a player receives 2 technical fouls in one game, then the player is ejected from the game. If a player is ejected from the game, then the player has to sit out the following game. Okay, sounds good. So if we get technical fouls, I guess I'll put an F for fouls in one game, then the player is ejected. If the player is ejected, see how we're starting with ejected next. If the player is ejected, then the player has to sit out the next game. Notice that we have our E's that match up. So we can go ahead and write this statement if, and I'm just going to really abbreviate here. So if 2 technical fouls, then player sits out. Now, whenever you have your quiz coming up and also in your homework, I do want you to write it out, but you're not going to have one that this is this long. This is crazy. Okay, before we go to C, let me backtrack and let's go ahead and show the official setup on the law of detachment. So if 2 angles have the same measure, then they are congruent. If 2 angles have the same measure, then they are congruent. You know that the angles have the same measure. So then we can say, therefore, the angles are going to be congruent. So this is the official notation for the law of detachment. Let's go over to the gym. So if it is a weekday, then Jesse goes to the gym. Today is Monday. Therefore, Jesse goes to the gym. I'm just going to put gym there. Again, official little notation there. Let's go look at our third one. If a triangle is equilateral, then all the sides are congruent. If a triangle is equilateral, then all the angles on the interior of the triangle are congruent. Okay, so let's see if we can get this right. So if it's equilateral, then all the sides are congruent. I'm going to put SC, sides are congruent. Then we have, if a triangle is equilateral, then all the angles on the interior are congruent. Okay, right away, this is not the law of syllogism because, or it's not a correct law of syllogism because the last statement of the first does not match the first statement in the second line. And so we can say on this one that law of syllogism does not apply. Does not apply. Looks like a science term there, DNA. Does not apply, though, for math. Next question, is this inductive or deductive reasoning? So remember that inductive. Inductive is whenever we're having a guess or it's based on a pattern. And deductive is a proven statement, like a definition or a theorem that we haven't got to yet, something like that. So let's look at this first one. The runner's average speed decreases as time spent running increases. Is that always true? That's what we're asking ourselves. I'm going to say this is inductive reasoning. I mean, it makes sense. This is based on a pattern. But do we know every single runner in the whole wide world that follows this? So this is inductive reasoning. Not always going to be true. Now let's go to B. The runner's average speed is slower when running 40 minutes than when running for 10 minutes. And we're talking about looking at this graph right here. So the average speed is slower at 40 minutes than what it is at 10 minutes. So we can show for this person, this is absolutely true. And so this is going to be deductive reasoning because it's based on data. And it's proven data because we took data, we took official records. So this is going to take care of it for our section 2-3 with deductive reasoning.